So keep going to number 4, question number 4 for section 2.2. So after we learn from the first video, we learn the end behavior. We learn the end behavior, so we can practice with question number 4. So if it's a function, this is a function, how you check the end behavior? End behavior, you have right hand side and the left hand side. Right hand side goes to s goes to positive infinity. Left hand side s goes to negative infinity according to the coordinates, the real number 9, numerical 9. So x axis. So this is when s goes to positive infinity. This is when s goes to negative infinity. What happens? So this one you have the leading coefficient. So when you are talking about x goes to positive infinity, basically 4 is really, really small. So this goes to negative x to the 8th. It doesn't matter you want to plus 4 or you don't want to plus 4, just doesn't matter. When x is very big or very small, plus 4 is still very big. And or if x goes to very small, then you plus 4 still very small. So that's how I show my work here. When x goes to positive infinity, you follow the function. 4 minus infinity, if positive infinity, if you have a degree, right? A degree is still infinity. So 4 minus infinity is still negative infinity. You plus 4 or you don't plus 4 doesn't make any difference. Still negative infinity. Okay. Now, when x becomes negative infinity, because the a degree is an even degree, so the negative sign disappears, become positive. But keep in mind that you still have negative sign outside the parentheses. So the whole thing is negative infinity. And outside you have plus 4. When you have negative infinity, so big a number, doesn't matter you plus 4 or you don't plus 4, still negative infinity. So this is a very good example for end behavior. Now, after this one, we have a video earlier from question 3, talk about end behavior, and the number 4 is just a review or an example for you. Now, after this example, I want to show you. You can see that the eighth degree is only for x. But if you have a function, totally you have eighth degree. Everything inside the eighth degree. I mean all the x. Okay, inside 8 degree. Outside you may have some number but not x. Or you have y equals to k times x minus a to the 7th degree. Then it's different from you plus some number outside, okay? If you multiply some coefficient outside, it's a bit different from you plus 4. Now, if you have a form of the polynomial like this, all the plus minus is inside the parentheses. Then you have how many zeros? Looks like there's only one answer, is x equal to a. But the x equal to a how many times? Many, many times. So we say x equal to a is the multiplicity of how many times? K times, or in this case we have 8 times. So when I was young, we learned we have to write down answer. For example, this A times 1, 2, 3, 4, 5, 6, 7, 8. I need to write down A times. Okay? Because this eighth degree, I supposed to have 8 solutions, even though there's a duplicate, same 8 times solutions. And in this case, then you write down A, 1, 2, 3, 4, 5, 6, 7. I need to write down 7 solutions. Okay? But right now here, we say just a multiplicity of K. When K is odd number, so we say the degree K is odd or even, then it will make your graph different. I think we talk about that. Oh, okay, I can talk about one more time. Okay, so let me erase here. Too many marks here. It's better this way. Okay, so pretend K equal to 8. If K equal to 8, when S become positive infinity, what happens? You may ignore. So it become positive infinity to the A degree, and it become positive infinity, right? And when you input the negative infinity and the minus A to the A degree, now negative infinity, you take away some numbers, still negative infinity, no change, to the eighth degree, and still positive. So that's when K is an even number. For example, 8. Okay, that's the first example here. Now when K is odd number, so let me change this K to the odd number. Then what do we have? So if I change this K to become 7 degree, okay, 7 degree. So infinity minus A still infinity, right? So this goes to 7 degree and still positive infinity. But when you have negative infinity, when x is very small, you minus A, still negative infinity. But when you go to 7 degree, because this is odd number, so it becomes negative. Okay. So number 1, when you have an odd graph, when x is very small, y is very small, and you may go up, down, and in the end you go up. Okay, let me read graph. So you may have this one in the end. Okay, and when k is even, then you change to another color. When k is even, then I have a graph. They both go up. So I go this, and go up. Okay. So this is number 1. After number 4, I give you more information. We call this repeated zeros. Okay, repeated zero. Let me erase those marks. So when you have repeated zero, then you may have a, oh, okay, I graph wrong. Why I graph wrong? When we have repeated, then you don't have so many xy intercept. Okay, so it means even you have this. Okay, and you have only one x-intercept, A0. See, you have a, if you have many, if you have high degree, oh, so sorry, I graph wrong. Okay, here. So you have the only one x-intercept. So this is y equals to x minus a. For example, that's eighth degree. Let me change the right color if you have this color. So you have y equals to s minus a to the eighth degree. Okay. So you're supposed to have a degree. You're supposed to have 8. You're supposed to have 8. Let me choose the light color. You're supposed to have 8 x-intercept like that. Like I said previously, I graph wrong. Yes, if you have 8 degree, you're supposed to find 8 x-intercept. And this 8 intercept happen to merge together, become the same one. So 1, 2, 3, 4, 5, 6, 7, 8. 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2 more. Okay. Oh, okay. Okay. Say we're supposed to have 8 x-intercept, but those intercept all merge together to become one x-intercept. So we say hold everything squeeze. This one merge to here, merge to here, merge to here, merge to there. This one merge to here, merge to here, merge to here. So everything, you kind of the whole graph merge to here. So in the end, you have the blue color. Okay, so in the end, after merge together, this will be gone, right? Everything merged together. Okay, same idea to number 1. So earlier, I kind of graph right, but not graph right. Why? Because let me use this color. Right, the graph is supposed to be like that. But again, we understand if you have 7 degree, for example, if you have 7 degree, then you want to have 1, 2, 3, 4, 5, 6, 7. You want to have a 7 x-intercept. And those 7 x-intercept, what happened? They merge together. Okay. Let me use the color block. Right? Those 7, if they merge together to 1, and let me choose the red color. And this one goes to here. And this one goes to there. Okay. And everything merged together. So in the end, you have the graph of the red color only. Okay. So this is one new thing we learned. If you have a form of a totally complete k degree, then your graph will be very simple. Let me graph better for you. Okay, let me change the color. Let me graph to the grid. If it's odd, then you have one up and one down. All the other x-intercept merged together. You have only one x-intercept. Okay. Next, number 5. Here you don't see complete any degree, so you have the regular. So we may assume you may factor to 3 factors: x, s, s. That's at the most. Sometimes it's possible like that. Okay, but right now we say at the most. So when we say at the most, we assume there's no multiple factors, the same factors. Now at the most, you may ignore those, because compared to the highest degree, you may ignore the rest. So in the end, we only for check the end behavior when s become very big. When s goes to positive infinity or negative infinity, you may ignore those lower degree. And then when s is positive infinity, you have negative 3/4 times positive infinity to the cube. So it will be negative. We only care about positive and negative, okay? When x is negative infinity to the 3 degree, this is outside is negative, inside the parentheses negative. So in the end you have positive. So this graph, to the right hand side you have positive, to the left hand side you also have positive. Interesting, okay? And then in the middle you may have up down or something. What happened? We don't know. Okay, but you have two ends. This two end, this right end, this left end. Okay. So the graph rise to the left. Yes. The graph falls to the right. Oh, yes. The graph falls to the right. Yeah. Yes, you are right. Because this is negative, right? So the graph falls to the right hand side because this is negative. Okay. Let's go down. Let's go up. Yes. Okay. And the number 6. Now this is same thing. This is not what we talk about the complete square. No, this is not a complete square. So the end behavior, we only talk about x squared, negative x squared. Now first they ask you to find all the zeros. When you want to find all the zeros, you simply solve for 0. Okay. And do you see any multiplicity of 0? No, because that's not a perfect square. So none. Next, we want to talk about what's the turning point means. Turning point means when your graph try to turn from go down and become go up, decrease to increase, or increase to decrease. Doesn't matter, just we call this turning point. Now, let me show you the definition. So we say at most. At most means sometimes when you have a duplicate, then you have this zeros. But at the most, we have how many zeros? We keep talking about the same thing. So let me graph for you. So say we have n degree, you have so many zeros at the most, right? And depends on even or odd. If you have even, looks like that. If you have odd, then it looks like this, right? So that's even or odd. And it depends on the coefficient. If your coefficient is positive, okay, so you may have something like that. If your coefficient is negative, then you have that, or you have this. Oh, okay, that's all the possible. Depends on the coefficient. One up, one down for the odd. Okay, so odd you have one up, one down, or one up, one down. And even you have both up or both down. This kind of formula for your idea. But doesn't matter for which type of situation, you're supposed to find at most. So if you have n degree, you have at most. You have at most n real zeros. That's very important. Okay, if degree n, you have at most n real zeros. Let me change it to red color is better to point out how important it is. So if you have degree n, then you have at most n real zeros. That's the explanation. Because you are able to factor at the most x factors, n factors. So if you are able to find the n factors, you have n x-intercept. So you say n x-intercept. When you have n x-intercepts, let's make it a smaller number. How about n equals to 5? How about that? So that n equals to 5. Let me make it easier for you to understand. So when you have n equals to 5, okay. So n equal to 5, then, for example, you have this, okay. You have 1, 2, 3, 4, 5. You have at most 5 zeros. And at the most of 5 zeros, you can see very interesting here. Do you see the maximum, minimum, we call local or relative? That's the new vocabulary word. Oh, let me change other color. Okay. So you have local, maximum, local, minimum here. How many of them? n minus 1. Okay. So start from the number 1, x-intercept, and when you go to number 2, x-intercept, you find 1. And when you go to the number 3, x-intercept, you find another 1. And when you go to number 4, x-intercept, you find another 1. Goes to number 5, x-intercept. So you have 5 x-intercept And start from number 1, you find 1. Start from number 2, you find 2. Start number 3, you find 3. Start from number 4, you find 4. And keep going to number 5, you cannot keep going to find anymore, right? So if you have at the most 5 zeros, n equals to 5, then you find at most 4 turning points. Turning point basically is the relative minimum or maximum. So you say n minus 1. So the formula for the turning point is n minus 1. If you have n zeros, you have n x-intercept. Therefore, you have n minus 1 turning point because the last x-intercept you cannot find any more turning point. It's not going to turn. The graph is not going to turn to anywhere. Just keep going, no turn. And whenever you turn, you have a maximum or minimum. So other book we call local maximum or local minimum. And here we say relative minimum or relative maximum. So it all depends on you increase or decrease, no matter what. When the graph from increasing to become decreasing, then you have one turning point. From decreasing to become increasing, you have another turning point. So that's how it happens. Number 7. You want to find the zeros. First, you want to factor. The first step of factoring is pull out the common factor because you have all the x. And then you may try to factor by Fourier. This type of the calculation we learned it from algebra 2 because in this special case we have all the x squares and this x square. Okay. So you may solve factor to the x square and then solve for x square. When x squared equals to -8 means there's no real. So you don't have, we say we have at the most 5 zeros, but actually we only find 3 zeros. Why we only find 3? Because we lose 2. We lose 2 zeros to the, because that's imaginary number. So here we only want to look for the real zero. Real zero, then we can graph. Imaginary solution is important to find, but we can never graph the imaginary solution. So when it may happen when you have imaginary solution, your graph is float in the air. Then you have no x-intercept. Now be careful, part 8. You want to enter your smallest number here, large number there. I kind of didn't put it on the right position, okay? So I put my largest number here, and okay. So if you try to follow the homework section, you want to say smallest one is -√7, and the largest one is √7, and you have a 0 is not the biggest, not the smallest. And is there any multiplicity of the 0? No, you don't see any multiplicity. Okay, when you see the whole thing square or whole thing cube, not the inside. Okay, if the outside you have square or cube, then we say that's a multiplicity, but not in this case. So we don't have this. And how many turning point? We say at the most 5 minus 1, 4. But actually, in this case, we don't have so many turning points. We don't have 4 turning points. Why? Because we lose 2, right? So follow the formula. N minus 1, you're supposed to, at the most, follow the formula we say at the most. But actually, we don't have. Because you only find 3x intercept. You only find 3x intercept. Therefore, you have only 2 turning point in this case. So 3 minus 1. And the 5 minus 1 is at most. And in the real situation is only 2 turning point. 1 maximum, 1 minimum. Number 8. Number 8 is type of question. It's special because earlier I give you polynomial and ask you to solve for the zeros. But right now I give you zeros. If I give you zeros, you understand something equal to 0, you solve for it. So x, we always use subtract. Why you use subtract? Because after you plus, x equals to this number. So if you have a 0, a, then you take away a, you have the factor. So this is the a. Okay? If a is a 0, then x minus a equals 0, then x equals to a. So when x equals a, you go backward. X minus a is 0, and then x minus a is one of the factors. And this is another factor, is a1, a2. So when you have 2 zeros, you say a1, and a2 means x minus 15 need to be 0, and x minus negative 3 need to be 0. Okay? So x will equal to negative 15, and x equal to negative 3. We say or. Okay. Therefore, we factor to x minus a1, a2, and multiply them together. You have the polynomial. We did this from algebra 2 before, and the same question. If you had two zeros, then you take away these 2 zeros, and then you have 2 factors, and then you multiply that. This time, this question number 9 is so special. Why? They said there are many correct solutions. Why is there are many correct solutions? Because you have 4 degrees, but they only give you 2 answers, and only 2 answers. If you have only 2 answers, that's one possible is you have negative 2 duplicate and the negative 1 duplicate. That's one possible. Or you have negative 2 not a duplicate, but the negative 1 you triple. Or that's possible, negative 2 triple, and the negative 1 only one time. So I did all the 3 possible way. Okay? 3 possible way. Oh, that's another possible way I didn't this. Or P is x plus 2 and the x plus 1 cube. 3 possible. Number 10. Number 10, they ask you to use a graphing calculator to graph, but actually, you can kind the graph by hand. So you can check if you try to plug in -2 and the +2 to the x value, you can see that when x is +2, you need to have negative, need to go down. This graph need to be there, so that's not right. When x is +2, you plug in. Okay, so +2 is here. Need to go down, right? But this graph is positive, so that's not right. Okay, so we don't choose this one. And the same thing, you can test to see right or wrong. And the only thing right is this one. So when it's 2, supposed to be negative here. So very detailed, right? So when x is +2, -2, y is negative. That's correct. And the end behavior, you can check, is correct. And how many x-intercept, you can plug in to check. When x equals 0, what happened? When x equals 0, y need to be 0. Okay? So the first graph kind of almost correct, except the x-intercept goes to the wrong position. That's a wrong x-intercept. The correct x-intercept is where? Wow. Oh, they have the correct x-intercept. But even though they have correct x-intercept, no, that's not correct. The x-intercept need to be greater than 2. 1 is 0 and 1 is greater than 2. 1 is smaller than -2. So anyway, you need to find the x-intercept. They have 3 x-intercept. 1 is 0, 0. 1 is greater than 2. Okay? 2 and 3, 2/3. This is -2 and 2/3, 0. So you have 3 x-intercept. And here you have a duplicate 2 zeros. So that's why. If you don't have duplicate, then the graph supposed to go this way or go that way. Okay? But why the graph didn't go 1 up, 1 down? Because you have duplicate. So that's why. Duplicate. You have 2 zeros here. Okay? So let's go to number 11, the very last one. This one, I say it's kind of beyond your ability to understand. First, if you take a calculus, you may learn the slope of function g is, we use this notation on the calculus, and then the function will be follow the formula. I can just mental calculate for you. You have 3 times the coefficient, 2 times the coefficient, 1 times the coefficient, and the 0 times the coefficient, then become 0. Okay, so you have -0.009t, and then become square. Why is that? I cannot tell you right now, because what? You have not learned enough to understand. So after you multiply the coefficient, the degree to the coefficient, then you have 1 degree, and then plus 0.456. Then that's the slope formula. So your graph. So if you use graphing calculator, you can graph. You can choose the first one for the right graph, and then so many points on the graph. Each point have different slope. So I roughly graph the slope. They are changing. Each point have different slope. So that's the slope function graph. That's the original graph. And for this part, how do I know this quickly? I can figure out the slope graph. I cannot tell you again. Okay, you need to learn calculus. But how come this book asks you to understand this? Actually, they give you the function. Do you see that? The same thing. I don't need to copy. I can figure out by myself because I learned calculus before. And this is the slope function. Okay, slope. Slope of what? Of the graph. Then why we want to talk about the slope of the graph? So you don't need to worry about the function because the question give to you. Now, the concept is the slope means you increase fast or slow. So this is increase. And sometimes the slope here is a negative slope. Negative slope means decrease. And the positive slope means increase. So this company, for example, this is this company growth increase. But the increase is the slope. Sometimes you increase faster, right? And this increase not that fast. If you compare this increase and this increase, which one increase faster? This one faster. This one slower. So we want to compare each point at which point or at what time the increase faster, and then in the end there's no more increase. You see, slow down, and probably become decreasing. It's possible. Okay, kind of become decreasing. Do you see that? So when the increasing from slower become faster and slow again, this is slower again, and become decreasing. Wow, do you see that? So that's very interesting analyze to this graph. And the question is, when is the fastest increasing? So I kind of guess when the increase is the fastest. From my graph, looks like this is slow down again, right? Let's slow down. Slow again. So the fastest possible increase, I guess, looks like here, right? So after this one slow down, here you faster, right? You faster and then slower and slower. So this number 15 is a very important point. And why you have to learn this so early? Because soon you are going to take a calculus. Okay, so we want to, in the beginning, we want to start thinking about increasing faster, increasing slower. When you increase slower, the slope formula will be different. Okay, so let's try to answer this question. When it increases the fastest, when the year is number 15. Okay, and you don't know this. I say, haha, you don't know. Okay, and because this is second degree, when the slope formula is second degree, then you can figure out what's the maximum. Because this is negative. Negative, the graph is this. You are going to have maximum. So when you have maximum, when x equals to 15, you are going to find maximum. How you find 15? By formula. Negative b over 2a. So b 2a. See? So you have about 15. I guess right. So the real answer is 15.333. I guess pretty close. 15. Okay? And when it's 15, you are going to find the maximum. You plug in 15 to the original function. or from the calculator, they may show you this number, 2.572. You can use graphing calculator. So this is the vertex. This is also the vertex for the quadratic function. Now, there's one thing I want to show you. When you try to use graphing calculator, very important thing is how to set up the window. If you set up the window wrong, then your graphing calculator may not graph for you. So that's my example, how I set up the window for this question. Okay, so you can try, and if you have more questions, you may ask me in the class time online. So see you next section. Bye bye.